Today I'll have a brief overview of Bayes' theorem. So Bayes' theorem is stated here in this equation. So there's a few terms to know. So here's this gray one. It's the probability of A given B. So that is basically, so in English, this is A, some event A, given that we know that B has occurred. Probability of A intersect B, which is that A and B both occur. And finally, the probability of B. That's just vanilla probability of B occurring in the first place. So here's just a little bit of an example here. Let's take A to be that I drive to my friend's house, and B that it snows today. And let's just assign some probabilities here. So obviously different people would be different, and we don't actually have real weather conditions here, but let's take the probability of A to be 50%, probability of B to be, or the probability that it snows is 25%, and let's say I'm mostly risk averse, but let's say the probability that I drive to my friend's house and that it snows today is 1%. So even if it snows just a little bit, I might go. But if it snows really bad, I'm definitely not going. So we want to compute the probability of A given B. So just to review that formula, let's just recopy it. It's the probability of A and B occurring divided by the probability of B. And so you just plug these values in. So the probability of A and B, we said that was 1%, and the probability it snows in the first place is 25%. So this is 0.04 or 4%. So it's not very likely that you're going to drive to your friend's house, but it might happen depending on the conditions. If it snows not too heavily. So let's answer a slightly different question, which is the probability that it snows given that I drive to my friend's house. So this is the scenario where your parents are out of town, for example. They call you and you say, oh, I'm at my friend's house. And they want to know, well, based on this information, what's the probability that it snowed today? So we do the same formula, but we just switch the roles of A and B. So this is the probability of B and A divided by the probability now of A, because we flipped the roles. This term here and this term here are still the same. There's no difference between them. But here on the bottom now we have this slightly different term. That's the probability of A. And so this is 0.02 or 2%. So if you happen to be at your friend's house, it's not very likely that it snowed, but it could have snowed, and then you still made the decision to go. So hopefully this is an intuitive example that helps you understand Bayes' theorem.